plastic leakage at a global level. Yeah, and it's our pleasure to welcome you here in this third call. It's about, as I said, tackling plastic at the global level, and we have a special input today from our dear colleagues from University of Leeds, formerly now Imperial College London, on a very interesting AI-driven tool, which takes quite some lessons and different data sets on board and extrapolates tools we have listened in before, from starting at the municipal city level towards national level plastic assessment and action planning, and now featuring basically a global overview about key indicators in the context of plastics 3D, and plastic leakage. And before we do that, we'd like also to remind on some housekeeping rules. So during the presentation will be recorded, and recording is already on. So if you're not very comfortable with that, we suggest that you leave your camera off and just listen in. Kind request to mute yourself while you're not speaking, and use the chat function for questions you have during the presentation. We have Annika with us, who moderates the chat. And that's being said, I think I would then hand over to our first speaker, Costas Velis, a lead researcher on various plastic leakage hotspotting methodologies. And we have his teammate, Cottom, also very influential and well known in the sphere of plastic leakage assessments, doing the second part of the presentation. Costas, over to you, and very interested in that discussion coming afterwards.
Good morning, good evening, everyone. Thank you so much, Stefan, Annika. We're grateful to the Prevent Alliance for the opportunity to showcase our work here, and hopefully make it further available to be used around the world. So I will share my screen. Yeah, no, that's not the right button. Let me do that right, because I always get confused. Hopefully I can press the right buttons here. And So today we're going to be covering this tool called Spot. This is a local to global, as we call it, tool that provides an inventory of solid waste management, and as an additional layer, it quantifies plastics pollution. And I'll be doing that with together with Dr. Cottom, so I'll be turning turns in presenting that, starting with me. Very quickly, just because most of you, if you've been following our research and activity over the last decade, our team has been based at the University of Leeds in the UK, and over a year ago I moved to Imperial College London, and our team now is based there. And hence the slide, so you don't get confused. We are at Imperial College now. So first, starting with the Spot methodology itself, a bit of the history of what we're talking about here. It was developed over many years and with support from multiple sources whilst we were at the University of Leeds, and we continue its development in the last year when I was at Imperial, and we'll keep on that. Major support received by United Nations Habitat Project and the COP-CNC Circular Resources. And then we had applications of it into Indonesia on a national variation of the methodology under the CRF on the PISIS project, and so on. As you can see on the other side of your screens, we had the pleasure of having these published on one of the most prestigious academic journals also of the world, Nature, back in September 24th, in between INCs. It is not just the results presented there, but in the repository of Dryad, and we provide the link here, everything is available. Input, output data, and the full code, which anyone can use it, even for profit, for consultancy purposes, because this is under a CC BY license. So if you use it and acknowledge that who has made that and your source, that is really possible. We're talking about operating under what we call full open science regime here, because we really want to see positive change. We want to see application and impact from this tool. So very quickly, moving on framing what this SPOT is. SPOT is an abbreviation of the impossible to pronounce longer version, spatio-temporal quantification of plastic pollution origins and transport. It is a methodology, but also translated into a model that produces outputs. It has, if you like, two core interconnected parts. First is a material flow analysis that quantifies waste management and plastic emissions. And second is another model that is linked to that. It tells you how it moves into the environment, which we already have a beta version. We'll be talking about that towards the end of our presentation. But we're mainly preoccupied now to explain to you this first part A, as we call it, which is the waste management and the emissions from that as plastic pollution. It's mainly coded in R for those who are a bit more on the scientific side, and the QGIS. That's the way that is quantified. So how does this work? As Stefan nicely explained, this is about tools and methodologies today that cover the global, if you like, picture, an overview of what happens across the world, and SPOT can give us that, but it has the added benefit that it starts with local data. So it starts with methodologies and data collection procedures that feed data on a local data, on municipality level, on local authority level. And by working on that, the results can be aggregated to any level, national, regional, and so on. It also tries to help us understand what we're talking about here, because unfortunately the science is young, the area is populated by all sorts of different attempts to talk about plastics pollution. So there's a bit of confusion between mismanaged waste, emissions, leakage, and so on. We provide some definitions as part of the methodology here, simply saying that emission is that plastic material has moved from a controlled and contained state to being uncontrolled, uncontained, out in the environment where it shouldn't be. A simple example to explain that a bit more is a dump site. Now, a dump site is not an engineered, controlled place to dispose of the waste. It's not an acceptable way. It has loads of environmental and human health challenges associated with it, but still, it is a place. It is a dedicated place. So definitely, a dump site is a mismanagement of the solid waste. But in terms of plastic pollution, one could argue that not everything there automatically becomes plastic pollution, because there's a basic level of containment there. But if you set it on fire and the plastics start breaking down, converted to CO2 and chemicals and particles, or if the surface runoff comes and takes some of the plastics to the river on the land, then it would have become plastic emission. So others referred to on the plastic emission with the term leakage, which is a non-technical term, or sometimes the term release is used, especially in the I&C jargon. The terms release and leakage have been used in a similar way that we use the term emission here. I'll move on now and offer you a bit of the methodological elements, and why that, not because I think you're interested into the nitty-gritty scientific credibility here, but because all these modular components are things that are also can be used separately somehow but explain the internal mechanics of the model and what information it processes and what outputs can give. I have some feedback, so okay, feedback is gone, so I'm sure all have their microphones off. Thank you. So first, as I said, we're starting on a local level. What does this mean? We go on international initiatives and methodologies, not least the WasteWise cities, the WACT toolkit, but also the UNSD reported data, the waste-aware water waste. We'll expect to see the water waste 3 sometime very soon, but also national databases there. And of course, these have a bit of a problem of standardization, but I'll come to that in a minute. And then we're looking also how are the many are the local authorities and which are the local authorities. These are diverse across the world, country by country, that we use that data to create a grid around the world and an input. And then we try to quality assure these and harmonize this data at municipal level, the solid waste management data. This is a critical thing and is a key missing factor on current global and even national level efforts, because as you see, then we'll use this to input into an artificial intelligence model. And this artificial intelligence model are even more reliant on quality data than even classic statistical methods. So we have created, as part of this effort, the most comprehensive database to date on municipal solid waste management data, and we have harmonized it. And in terms of global population, it's covering around 12% of the world. Then we moved on to do a sort of modeling, because we have some 50,000 municipalities, but only say we covered some 550. So there's a huge gap on what we don't know around the world. And we will never be able, in the foreseeable time, to know all these things. But the machine learning, the artificial intelligence, gives us now new opportunities to cover this gap with much more certainty and refinement that we could do before with classic statistical methods. And we use developmental indices like GDP per capita, purchasing power parity, and things like that, to associate with waste management performance, which is something we have proved that it's working on another paper earlier on. And then it comes to the super nice part, that is a model of many, many models, because the model describes multiple realities and phenomena that could be happening around the world. For instance, you have an uncontrolled disposal, a dump site, how the plastics are getting into the environment from there. This is totally different from what happens from your streets or during the informal collection and sorting, for example. So each of them has a dedicated submodel that we describe, and is a subroutine that we could use and start developing into more sophisticated ways. Or as the scientific certainty improves, you can replace it, aspects of that or the whole model, with something more sophisticated, with something more reliable and more precise. And that's the beauty of having a modular model that describes different things that are somehow disjointed, and you're bringing them together in an overarching model. And then we conduct a material flow analysis, which is a very basic tool, of course. A lot of other tools depend, like the waste flow diagram, for example, depends on a similar material flow analysis. And then in order to calculate the uncertainty, there's loads of uncertainty involved here, we do what we call a probabilistic material flow analysis. We get the results at the municipal level, and we can aggregate them, as I said, at any level that we want. So how does this material flow analysis look? You can get a simplified version, or can get a bit more sophisticated ones. This is a balancing act here from all the complex situations of what happens with the waste on the world. and the simplicity that we're trying to strike, because as we complicate the models, we're introducing more uncertainty, we're introducing more factors that we need to know in data points, so it make it more data hungry and more complex to calculate. We try to strike a balance. So it took a lot of effort to conceptualize and think and distill decades of hundreds of researchers into a generic, generalizable structure of what happens to the waste not at the simplest possible way. This structure then is basically a material flow analysis for municipal solid waste with an additional layer applied on the plastics that gets us all the plastics. So that's why this model gets us results also for municipal solid waste, not just on the plastics pollution. Then another amazing functionality of it is that it's really built in a fully compatible way to estimate the Sustainable Development Goal 11.6.1 that quantifies how much of the percentage of municipal solid waste is collected and managed in controlled facilities. This is, of course, in the very first place, quantified through the WACT, which you have seen in the first seminar, and gives you a first estimate on the local level if you plug in the waste flow diagram. But if you want to do it in all municipalities around the world, you need something like this tool to generalize for a few hundred cases to the tens of thousands of municipalities across the world. So what this model tells us, it tells us loads and loads and loads of things, but on a higher level, it tells us types of sources of plastic pollution emitted in the environment. Littering, like in touristic and city centers in affluent places, uncollected waste, what happens on the collection system, because still some will escape, what rejects you have during the processing, for example, when you're sorting. And then at the disposal phase, depending on the level of containment and engineering, then will be losses and emissions from there. We diversify through two major forms of emissions or leakage, either physical aspects, debris, or open burning. And this is really important, as we'll see very soon from Joss, that the open burning is such a fundamental problem that is happening on the ground, is a very big scale. We cannot ignore it. And this is the first model to very fully incorporate it in a sophisticated way on board. We also differentiate in two emissions, rigid and flexibles. This is not very sophisticated, but is good enough for multiple levels, both in terms of being targeted material for recycling and in terms of fundamental physics behavior and further dissemination in nature. We have the results on multiple scales, and as you can see here, it can be aggregated on different scales. So this is a bottom-up inventory, and when you saw the results on a country level or a global level, we still have the fine detail in there that can help us move across those scales and geographies and different aggregations however we want it. The other thing is that this is one of the few models takes substantial efforts to quantify uncertainty. There's huge uncertainty associated with this phenomenon because the science is young, because of the nature of the measurements, the data availability, and so on. What you see here is the results at individual cities with their uncertainty expressed as a probability density function. And the x-axis, you see a logarithmic scale on the magnitude of the plastic pollution. So despite the uncertainty that is explained through the probability, we still can see orders of magnitude difference between places that don't have good waste and resources management and places that have a much improved waste and resources management. We can see these effects, quantify them, describe them very well. I'm going to hand over now to Dr. Joss Cottom, who's going to drive us through first the results and then some interoperability of the spot model. Joss, over to you.
Thank you, Costas. I'll just quickly share my screen. Okay, hopefully you can all see that okay. Yeah, so In terms of a very quick overview of the results that we found that 52.1 million metric tons of plastic was emitted into the environment in 2020. So this is, an awfully high amount. And to give you some kind of context of what that would look like, if we were to pile this up in Central Park in Manhattan, it would tower as high as the Empire State Building. So a huge amount of plastic, and that is just from 1 year. This is being released every single year. However, as Costas kind of alluded to, a lot of this plastic is actually being openly burned. So actually 57%, over half of this, is being emitted as open burning. And whilst it kind of can reduce a lot of the visible form of plastic pollution, this has huge implications for air quality, for impacts on climate change as well. So even though the debris goes, I think it's something that we really need to start taking more attention to. If I just go over to the right-hand side of this graph and talk about the emission sources, by far the largest emission source that we found was uncollected waste. And somewhere between 1 to 2 billion people we found in the world don't have any form of waste collection. And instead, they're having to resort to self-managing their waste by dumping it into the environment or often openly burning it as well. The second largest source that we found was dump sites. Now, some of this was due to kind of windblown leakage and from kind of surface runoff, but by far the largest part from the dump sites comes from open burning that was occurring at those dump sites. The other emission sources that we have in terms of the recycling system, the littering and the collection system were all relatively small in comparison, but these can be hotspots in certain regions, and I'll show that in a bit later. In terms of the types of place where we found the majority of plastic pollution coming from, so we broke this down in the spot model into 3 different archetypes: cities, towns and kind of semi-dense populated areas, and rural areas. Now, one of the problems that we had is that a lot of countries use a different definition of what counts as rural or not. So here we used a harmonized definition. And for context of what we mean by rural here is quite sparsely populated places with not many people. And because they tend to have lower waste generation rates and lower plastic consumption, we found that actually on the global scale, this was only 13% of emissions came from rural areas. In comparison, a lot more came from kind of these towns and semi-dense populated areas. They can be things like suburbs on the outsides of cities, which perhaps have a lot of people living there, but the waste collection and hasn't expanded into those areas yet. But cities also contributed quite a lot at 40% as well. In terms of the types of plastic, both rigid and flexible were fairly even. Flexible was slightly higher than the rigid. This is due to a couple of reasons. One is the value of the material is less for flexible plastic, so it's not being collected by the informal sector as much. But then also the kind of item properties of it making it more susceptible to being blown off collection containers and dump sites as well. So this map here shows what is the largest emission source by each country. So you can start seeing some trends. So in the global north, littering is the dominant emission source. These obviously are kind of countries which have widespread collection and controlled disposal. In the global south, the biggest trend we see is that uncollected waste is by far the largest emission source in most countries. There are a few countries which have relatively high collection coverage, say over 90%, but maybe don't have fully controlled disposal yet. So open burning is happening at those disposal sites. And those are ones which we found the largest emission source was this open burning. So as Costas mentioned, all these results are freely available. We really only kind of scratched the surface of what we found here. So if you are interested, please do go and read the publication and download the Dryad Excel sheets, which have all the detailed results in as well. All the code is there as well. We have also some results are available on the GPML Data Hub platform. So things such as the waste generation and the plastic emissions are available on there. And the results have also been included in the Sustainable Development Goals Report 2022. That is for SDG 11.6.1. So all of these results were for the year 2020, which is when we ran the spot model for. But our intention is to try to periodically keep applying the spot model using updated data, for instance, from other tools such as the waste flow diagrams, such as WACT, which have been applied a lot more times since our initial run of Spot, and be able to kind of get periodic updates and a time series of results. Okay, so I'm just going to take a step back a bit really here and focus back to what we talked about in the first session, if people were around for that one, where we gave an overview of the different plastic pollution assessment methodologies. So I'm going to talk about how Spot might be able to be used as a tool to try to harmonize these different methodologies together. So just to recap what I said originally is that there are a lot of different plastic pollution assessment methodologies out there. And we actually did some work for the World Bank a few years back where we developed a toolkit called PLAST, which went and reviewed all the different assessment methodologies out there. And we were able to characterize these by different characteristics, such as the purpose of them, the scale that they operate, and the scope of that work as well. So really this series has been focused on kind of the plastic leakage to the environment, plastic emissions to the environment, and the kind of MFA-based approaches. But there are a lot of other different ones out there. So if you are interested in understanding them, you can actually go to this link at the bottom, the PLAST toolkit, and download that and look at the different methodologies available. So there were, like I said, there's a lot of different available assessment methodologies that work at the MFA approaches, and this series has given us some detail on different ones of those. So we've had the waste flow diagram explained, we've had the spot model, the NAM tool, and the plastic hotspotting methodology as well. So these are just a small selection of them. But what I want to talk about really is how we can now go beyond kind of individually applying these methodologies and try to get to a more harmonized approach between them. So if we take the different scopes of the methodologies and plot them out in terms of kind of the life cycle, so each of these blue boxes is a typical kind of life cycle stage that these methodologies are applied at. So we have the upstream stage, which really is focusing on kind of the plastic production, plastic trade, and consumption of plastic. And then in the type 2 boxes, we have the kind of models that we've been talking about, which is the typical MFA-based assessment methodologies that look at the waste management system, then also plastic emissions into the environment. And then the type 3 methodologies, these really look at what happens to the plastic when it's in the environment. So trying to understand kind of where it's moving to, if it's moving to rivers and into the oceans. And there are several key points within this that we can try to harmonize between all the different methodologies. So for instance, between the kind of the upstream methodologies and the MFA-based waste management methodologies, a key harmonization point here is around the plastic waste generation rate. Both of them have this kind of this equal data point, so it can be an area which we can really try and harmonize between them. In terms of within kind of the type 2, within the assessment methodologies, the MFA methodologies, we found that a lot of different methodologies have different emission factors that are being used out there, different leakage factors. And I think it's important to try to get wider harmonization here. I say harmonization rather than standardization, because I think the different methodologies have different approaches that they use, and it's important to try to allow those different methodologies to apply different approaches. But what we want to try to avoid is different methodologies giving different results. We want to make sure that they're all kind of in agreement in terms of what, say, the largest sources are. And then in the type 3 methodologies, what we can have here is harmonization that links from what we're finding in the environment to what we are saying kind of the hotspots are or the emission into the environment are. So this can be done through things like environmental sampling. So just to give you a bit more of a kind of practical demonstration of that using the spot model, the spot model can kind of harmonize with different methodologies by using their data inputs. So as we alluded to, we can use tools such as the Wastewise Cities tool, such as the waste flow diagram, use their data, which has been already kind of quality assured, and feed that into the spot model, feed that local level data into the spot model to try and improve its machine learning capabilities. We can also take data from the national level assessment methodologies and feed that into spot model to try to use it as a source of validation and make sure that we're getting agreement. And then we can take data from plastic that we find in the environment and use that to try and validate the calibration validate and calibrate Spot's kind of movement and emissions side, which Costas is going to talk about in a minute. We can also use the outputs of the Spot model and feed those into other models. For instance, we could feed this solid waste management data into other assessment methodologies. So we know that data availability is a real concern with a lot of methodologies. So Spot can help bridge that gap by using its machine learning model to estimate this data for places which doesn't have data. We can also take its debris emissions and feed this into different kind of hydrological models that are out there. So we've already actually done this with a few, such as the DHI risk assessment model. And we can also feed it into river emission, feed the river emission outputs from Spot into oceanographic models to understand how this plastic is moving within the oceans. So Spot is a tool that we think is capable of really acting a bridge between some of these other methodologies that are out there.
So I hope that was more on the informative rather than the overwhelming side of things. We're grateful for the opportunity and your interest to see some comments already in the chat, but I'm going to hand over now to our chair, our host, Stefan. Over to you for comments and questions, which we very much welcome. Thank you, and over.
Yeah, thank you, Costas. Thank you, Josh, for a great presentation. I would be interested in, let's say, you called the model Spot. So I wonder if it did also put you in the spotlight in a certain way after releasing it, and what had been let's say, the feedback or the reactions from countries, from policymakers in the context of the Plastics Treaty, and maybe also what the scientific community, what was that feedback. Would be great to shed a bit of light on these 2 points, and then I think we can over to questions in the chat.
Brilliant. I can take that. Okay. Thank you. Thank you, Stefan, and just feel free also to jump in. I think, of course, as I said, this was published in the most prestigious academic journal in the world that publishes multidisciplinary world, Nature. It received a huge response in general, both from the academic community, but also from all the different types of stakeholders. This can be seen on the, we measure it actually what we call altmetrics. So it was a huge success. If you go on the site, on the Nature's website and look at the alternative metrics, how many people refer to it in the press, in videos, in public media, everything. It was a huge success, one of the most successful publications of Nature at the time, and a huge uptake and interest. So this was very reassuring that the topic and the capabilities and the outputs of the work are thought as very, very relevant. We had a lot of praise and a lot of interest. Also, we had a lot of controversy. I think this related to the fact that we dared, for the first time, to show national level results. Okay, that no one has dared do actually after the initial first jumping atoll model 10 years back, back in 15. And saw some surprises there, put some countries on the spotlight, disagree with the national official statistics numbers. We've also demonstrated other phenomena that were not so much on the public agenda, on the negotiations so much, like the open burning. Yes, it is there. Yes, we'll do something about it, but it is a small box ticking exercise while we're sorting the nature of the things. Also, we were caught into the debate about the importance and the relevance and the degree of waste management solutions, because unfortunately, the waste management has somehow hijacked by some of the stakeholders that didn't want to see any change. And then presenting a model that provides all this information and shows how potentially effective could be sound waste management in stopping plastic pollution at a huge scale, being the most prominent failure we're facing in the world, could be perceived by some stakeholders as telling that, no, we don't need upstream measures, or we don't need to focus on other phenomena. There was an interesting controversy about the exports, which we haven't fully modeled. Interestingly, I was the academic to raise that 10 years ago in this work about the unsustainability of plastics recycling exports when it was without any quality control and a lot of illegal activity was exported. But we thought that this was a small part. That was our initial assessment, and we ran this. It isn't. So this was perceived by certain players also as insufficiently blaming the global north and maybe not allocating enough responsibility. So it is an interesting debate, which we pretty much welcome because we think we need this level of scrutiny. We need this level of interest. We need also to have this uptake from the policymakers. So a lot of debate. We hope the new versions and the new capabilities when released to generate equivalent debate and interest. And I don't know, Josh, if you want to follow up on this or.
Just to add another point about the uncertainty, I think so moving kind of away from the academic side, but often sometimes I guess when practitioners are looking at the data and seeing how it compares to their place, it's very normal for us to go and look at kind of the mean result and ignore all the kind of the surrounding uncertainty that we have with it. But as Costas was explaining, kind of the trying to understand this uncertainty is really key for us in doing this. So yeah, we do have a lot of uncertainty at the minute. It has to be true. We have this uncertainty, and I think that can only improve with time by kind of trying to collect more data and improve the parts of the model. But saying that, there are certain results which, even with the uncertainty, we're very sure of. We're very sure that uncollected waste is by far the biggest emission source in the world, and so this can really help point to directions of the treaty that should be going. We shouldn't be ignoring things like uncollected waste, which are so important, and the same with open burning as well.
Okay. Yeah, thank you for giving that context to the model and the release of the model. I see already some questions in the chat, and I would like to hand over to Annika maybe for reading out the questions in the chat. And also we have one hand already, and looking forward for the discussion here.
Yeah, thank you very much, Stefan, and thank you very much for the presentation. With the first question raised was by Sibylle, and she would like to challenge the concept of plastic leakage, as she says that this is not a neutral term, but frames plastic pollution as a marginal failure of an otherwise manageable and circular system, implying that plastics are largely recyclable and that improved waste management, monitoring, and data can sufficiently address the problem, while also toxicity and systemic health impacts of recycled plastics are overlooked. And she would like to know if what your point of view is on the term plastic leakage. I know that you are using the term emissions, and I think it also dives into the discussions that you already mentioned, Costas, on the upstream versus improved waste management discussion.
Yes, leakage is a non-technical term. In the UN traditional documents that distilled science and engineering, the terms emissions and releases were typically adopted. Leakage is a problematic term because it has initially emerged into the circular economy debate and narratives, and therefore it had a different meaning there. So meaning as non-utilization. So something. This was the first layer of confusion, and then the confusion was exacerbated. I totally agree that the terms we use have implications on all sort of levels, and they have underlying narratives or can be interpreted in different ways. So that's why I propose the term emissions, which it's much more dry technical term. The difficulty we have with that is that it has been so widely adopted for gaseous emissions as part of the climate change. So then some people start misinterpreting that. We're talking about CO2 or wider greenhouse gases now, which we don't. We define as plastics in the environment as a pollution event, a new type of pollution event, either the whole plastic or its constituents or its products of unsuitable processing. And yes, this is not what we're describing through this model here is not the entire type of emissions. The emissions during the manufacturing of plastics, the emissions during the use phase through chemicals and their transformations and so on. Definitely it doesn't cover the whole spectrum and types of emissions. So I tend to agree with you that the term leakage now is problematic on so many levels, but there you go, we cannot get rid of it. So we start compromising ourselves and using it just because, despite that we think it's unproductive, it has so much traction even in the UN negotiation circles. That's it.
Thank you, Costas. And I think there will be a whole debate on definitions in the plastics 3D when it comes to that point. But thanks also, Sibylle, for making that point. I think it was quite clear. Yeah. Over to the next question, Annika. I think there are a couple of questions lined up. Yep.
Then we have 2 questions on input data for the spot model. The first is by Imogen. Is this, or how is local data inputted? Is this by your team or by others? And is this model still active and taking new data?
Maybe I'll come in on that one. So both really. We for the initial kind of application, the global application of Spot, we collected data that was already out there. So things such as the Waste-Wise Cities tool and the water waste reports. And then we kind of tried to harmonize those and correct those and feed them into Spot. And we want to carry on doing that process. We want to keep doing reviews and seeing what data is out there and feeding that into Spot to get this kind of periodic release. But as Costas kind of said at the start, the whole code and model is fully available to use for everybody. So there's nothing stopping people going out and applying it themselves and inputting that data. And for a case study, for instance, for a country that you wanted to apply it for, and running it yourself. So yeah, it really applies for both.
Okay, then one question directly connected to that from Tillman from Everwave. Everwave is an impact company focusing on the collection and mismanaged waste and the development of waste management in low and mid-income country. And one of their pillars is the collection of data on waste volumes and compositions. And his question is, what would be your recommendation on how to collect field data, place, time, format, parameters, manual, automatic, and how could this data bring the Spot model forward?
Well, yeah, I mean, it's excellent to hear that you work in a company that is focused on collecting this data, because we found that often this data isn't being collected. It's often missing, and it is a big data gap. So it's good to hear that data is being collected. In terms of kind of the methodologies to use, a lot of our work was actually going into trying to make sure that the data that we fed into Spot was kind of clean and harmonized. And there's a lot of different kind of nuances when you're collecting waste management data. For instance, kind of the point in the system that you're collecting it, that can lead to this data being inaccurate. But there are, a lot of tools out there that have been developed to try to improve data collection. So at the city level, for instance, the Waste-Wise Cities tool, that is a really good methodology that we have directly aligned with in Spot in order to take the data from the Waste-Wise Cities tool. And that tries to cover a lot of the kind of problems that we often see when collecting data on the ground, such as accounting for the informal recycling sector, or making sure that our waste generation includes uncollected waste. So I'd say that's a really good starting point if they haven't seen that already.
And if I may add, we need all sorts of methods in the future. I mean, we have the classic waste characterization efforts to understand the basic. However, increasingly, we need to see new AI tools. We need also to see tools are based on sensor-based systems, from satellites, unmanned vehicles to to cameras on the ground. We need different ways to start collating evidence, because at the moment we have in such a small data set because of fragmentation, because of lack of resources, but basically because it costs so much to collect this data in the first place. So that's a core area for improvement, but also a core area for innovation that will help us then move beyond that bottleneck. This bottleneck, however, we use AI here to overcome for the very first time this bottleneck with a lot of uncertainty. But we have some data. We cannot say that we don't have anything there. We have some reasonable fitting models that give us some predictions that are not too unreliable, I would say. So yes, we need better data. We cannot use anymore the lack of data as an excuse for not being able to act and prioritize action and do action planning and so on.
I would take the freedom to just chip in here with a little reminder that we have currently an AI accelerator program which looks at use cases for all material streams, to be fair, all over the value chain basically, and then identifies use cases, how different data sets could speak to each other and inform better decisions basically, or provide better services. Marine litter could be one use case, and I think the more use cases and the more kind of prevent members apply with their data and their solutions, the more likely is that this one could be prioritized in that accelerator program. Just as a little reminder on that one. And then, Annika, I think there are more comments here.
Yeah, but we also see one hand raised, so I think I would take the hand first. It was up beforehand.
I think it's Pankaj. Yeah.
Please go ahead.
Hello, hi. This is Pankaj from Doko Recyclers, Nepal. I'm also working in waste management and plastic waste management here in Nepal. Going through the presentation, I missed the previous few slides because I joined lately. But just trying the slide where you have quantified the plastic waste based on different parameters like the city-wise and the flexible and rigid, which is quite interesting because till now I have never found any study which just disintegrated the quantification in terms of flexible and rigid part. Just trying to understand, in your paper, it's already mentioned which plastics you have considered as a flexible and which plastics, what kind of plastic you have considered as rigid plastics, because sometimes there is ambiguity in some categories of plastic as a flexible and rigid. And next to continue in that, where you have shown the emission 2% from the recycling part. So is it like burning of plastic during recycling process or emission that is coming out during the recycling process?
Yeah, thank you. So regards to your question on the flexible and rigid, we align the spot model with the definitions that are used as part of the Waste-Wise Cities tool. So you're right, there is sometimes a bit of ambiguity between the two. And because our data sources came from a lot of different places as well, they're not always directly compatible. But we did try to harmonize these as much as possible to the definitions that were already available in the Waste-Wise Cities tool. And then your second question on kind of the recycling system emissions, most of these emissions that we're talking about there come from the management of the rejects. So from the kind of the sorting of material. If that rejected material is being kind of openly burnt or dumped into the environment, that is what we were finding was the main source of that emission there, rather than kind of, as you said, any other types of emission which do occur, but we didn't quantify.
Just to add on, so does this emission also accounts for emission from the cement factory where the plastics are burned as RDF or SRFs are burned?
No. These are not CO2 emissions. No.
Okay, sorry.
SRF, RDF is another area which we have a lot of expertise, as I've done my PhD on that, and I have a whole laboratory on that. But that's
Absolutely.
a totally thing, is a big problem of misuse of plastics also in South Asia as we speak. A big problematic area which we would need another seminar, maybe there, Stefan, on the balance between recovering resources and doing that in a way that protects the environment and the human health, but that's a suggestion for another thing. So no, this is not covered there.
Yeah, absolutely. Like choosing between the evils is kind of things.
Yeah, it shouldn't be the case. It shouldn't. But
Yes.
if you don't mind, there is a comment also from my good friend Piotr there, which I would like to comment upon and reply, saying that the uncollected waste or leakage or banning waste is there by design or promotion of single-use recyclable waste. And I think, Piotr, yes and no. Yes and no, because yeah, have we chosen what products are we consuming? We see this proliferation of the single-use products all over the world, and especially if you go in Southeast Asia, for example, you see far more flexibles in the composition there and in the plastic pollution, because there's so much single-use packaged products and the sachet economy, very, very high level there. But I wouldn't say that this description is accurate. This is a super complex systems. We're doing other work on system dynamics to describe the complexity and understand the interlinkages and arrive at solutions that enable circularity. They're outside the scope here. So we shouldn't uniformly and oversimplifying, putting the blame in one actor, in one part of the system, and transferring the blame across the line. We should look at solutions across the life cycle, decisive solutions, reduce material consumption, reduce health impacts, reduce environmental impacts across the life cycle to the benefit of all, win-win-win situations. I don't think by start blaming different parts of the industries that can contribute to solutions, we're really doing any good to ourselves. I think this divisionist approach is actually counter-effective here. That's my strong personal view on that.
Thanks, Costas. I think we don't have the time to debate a lot on that, but I think you know each other well and can continue. And also we have the hub, the Prevent Hub. So if that really, creates energy for a discussion there, I'm most welcome to offer the hub for that one. We have one last comment, I believe, Annika, the WAC application in Lebanon by Wuppertal Institute. And basically the invite to share some lessons here. Bocho, we made established contacts with Costas and Joshua and also ourselves to check in and see where we can help you in these studies there. And I believe the question from Mr. Müller-Kirschmann about reports on macro and microplastic emissions and health impacts. Costas, you shared the latest studies on these aspects. Was there any further question? I saw your hand in between, Mr. Kirschbaum.
No, thank you very much. All fine. So I have these. I will look at these two sources of literature. Thank you very much.
Thanks also. Okay, then I think we come to an end of that very interesting session, I must say, and also of that quite interesting series of different webinars. So we had featured 3 different levels of city-based, national and global level. We know that there are more tools out there, and if anyone feels like contributing to that, let's say, series of webinar sessions, we are always approachable and can add another one. Otherwise, we believe that these kind of series trying to cover a topic from different angles and at different levels it's quite a promising one, and encourage Prevent members to make suggestions or pitch basically ideas for webinar sessions. Annika and myself are very happy to facilitate where we can. Otherwise, Costas and Josh and everyone here in this call, thanks a lot for contributions. Very interesting. Will be made available without the confidential part in the hub, and looking forward to see you during meetings, webinars, and other kind of fora. And Costas, maybe the last words on your side also.
Nothing. We're grateful for that. It's much needed debate. Thank you for creating the structures to enable this debate, and we look forward to work in each and one of you. We're on the same page. We want the same thing, to see the end of the plastic pollution, to see science and engineering, sound science and engineering informing policy and action. So Thank you, Prevent Waste Alliance, for playing a key role in that. Thank you so much.
you.